Now we're going to work through a simple exercise in profit maximisation. Profit maximisation is something we teach because a lot of owners, particularly those who don't work in businesses, view their businesses as merely investments that have to produce a rate of return. And so the businesses concerned are generally trying to maximise the profits to get that rate of return for the owners. Now profit, as we know, is simply your revenue, take your costs. And we look at those separately because they can behave very differently as the volume of production changes. And let's have as a simple example, let's say we're looking at Mary. Mary has a business and she makes wicker baskets which she sells on Etsy. And she sells to the world, so she can sell them all for $40, as many as she can make. So Mary's revenue equals 40 times by the number of baskets. But Mary has costs. And as we know, costs is comprised of fixed costs plus variable costs. And the fixed costs don't change with how much she produces, and they're there whether she produces or not. Now, we'll say Mary's fixed costs are $150 a month. Yeah, that's heating, rent, cooling, and things like rates, taxes, and professional indemnity, public liability insurance, workers' compensation insurance, all the various government taxes and associated charges that get levied on businesses. Mary has variable costs because she has to pay herself a wage based on the amount of time she takes to make these, and she has materials costs because the baskets don't come out of thin air. And so there'll be baskets, there'll be glues, and things that go into the basket. And we're assuming that the law of diminishing marginal returns applies. Diminishing marginal returns also manifests itself in costs, because what it means is that the cost of each unit changes. And in this case, it'd be because when Mary does the first basket, she's fresh, she's excited, she loves making baskets, and so the first one is very quick to make. And she's very efficient, and so she only uses the bare minimum products to make the basket. But the more baskets she makes, the more tired she gets, the more bored she gets. And so she starts getting sloppy, she makes mistakes, and we start getting wastage. And so the costs increase. So if we assume that her variable costs are a quadratic function, at say 2 times b squared. And so what that means, if we graph this is B, these are dollars. So at 1, Mary makes $40 in revenue, and she makes no revenue if she doesn't make one. But Mary has costs. She has fixed costs of $150 a month, whether she produces anything or not. But on top of that, she has variable costs that increase her costs. So her cost structure looks like this. And so we see costs across the revenue, cost and revenue meet at 2 points. And this area in here is profit because this is revenue greater than costs. And if you see the point, there's a point in here which the revenue, the profit, the difference between the revenue and the cost is maximised. And so if we graph the profits, because profits are 0 outside of these points, because costs are greater than revenue. So the profits look like this. And so what we now want to do is to try and solve this equation mathematically, to try and find out what this is. So we write our profit function, 40b, take 150 plus 2b squared. And to maximise, what we do is we take the first differential with regards to b. So taking that first differential, we get 40 take 4b equals 0. And so what we find, solving that, we get profit maximisation at b equals 10. And as an illustration, if we plot it more precisely, because this is very imprecise, we have, this is one I prepared earlier using Excel, and we can see this is exactly the same point. The maximum point is hit at 10, because you can solve these things graphically as well as mathematically.